Hi, I'm Gorman from Codemanship with a short demonstration of test-driven development in Java. I'm going to be doing the Fibonacci number generator example. I'm going to start by creating a separate source folder to put my tests in. So we keep our test code and our production code separate. I'm going to declare a new test fixture and I'm going to name it after the class that it's testing. Okay, I'm going to start by writing a failing test. And I'm going to name the test so that it clearly describes what the test is. Couldn't be clearer. I'm going to start by writing the test assertion first, and I'm going to work my way backwards. So we're being prompted to declare some stuff here to make our test compile so that we can run it. This belongs in the source folder because it's production code. Okay, we declare this method here. Now I'm going to ignore this auto-generated comment because to delete it would technically be a refactoring. As a general rule, when we refactor we want our tests to be passing. At this point our test doesn't even compile, so we don't have the safety net we need to do refactoring. So I'm going to leave that for now. I'm returning -1, and the reason I'm doing that is because I want to see that the test fails in the way that I expect it should. I'm running JUnitMax in the background here, so it's run the test automatically for me and it's reported that the test has failed because it was expecting 0 but returning -1. So that's a meaningful test. Let's do the simplest thing possible to pass this test. And at this point, because we have a green light, we have a passing test, I can do the cleanup that I wanted to do. Now, JUnitMax runs the test for me automatically whenever it detects that I've made a change to the source files. If you don't have something like JUnitMax, you need to remember to run your JUnit tests after you refactor. Let's move on to the next test. And this would be the second Fibonacci number, which is 1. Again, I start with the assertion and work my way backwards. Start with the what and work backwards to the how. Oops. Okay, I save that. JUnitMax will run it and it will see it's expecting 1 but we're returning a hard-coded 0. Now what's the simplest thing I could do that would pass both of these tests? Well, something like this. Okay, our tests are passing. I've introduced a little bit of duplication which I want to remove now. Okay, JUnitMax not reporting any failing tests there, good. Let's move this private helper method that's been generated out of the way. And let's parameterize it so we can make it reusable for both of those test cases. Okay, no failing test reported. Now I can replace this here with a call to our parameterize method, and all looks good and we're ready to move on to the next test. Okay, so what's the third Fibonacci number? Well, that's also 1. It's 0 plus 1. This will fail because we're returning the position. The position is 2, so this is going to return 2, but we need it to return 1. Now at this point we can reuse this private helper method that we created in our refactoring. So that little refactoring we did has already made life a little easier for us. JUnitMax reports that the test fails. That's good news. What can we do to pass this test? Well, we probably need to introduce a branch, because we know that returning the position will work if the position is less than 2. But for our third test case, we just need to return a hard-coded 1. So what I'm doing here is I'm generalizing as I go, one test example at a time, which is a process that Kent Beck refers to as triangulation. Right, we've introduced no duplication, so we're ready to move on to the next test, which would be the 4th Fibonacci number. Which is 2 plus 1, which is 3. Now at this point we will expect our code to return a hard-coded 1, so this test will fail. Actually no, it's not 3, it's 2. I do apologise. So expecting it to be 2. But it's going to return the hard-coded 1, which JUnitMax confirms. So to pass this test I can do something very simple like returning position -1. Okay, all our tests are passing. No new duplication introduced again. What's the next test? Well, if we were to move on to the 5th Fibonacci number, we would actually have a test that passes, because a position of 4 in the sequence, 4 minus 1 is 3, and it just so happens that the 5th Fibonacci number is 3. So this is not a failing test and is therefore not very interesting to us from a TDD perspective. The next failing test that we might be interested in is the 6th Fibonacci number. Which is 5. 3 plus 2. So this is at position 5 in the sequence. So it's going to return 5 minus 1. It's going to return 4, but we need it to return 5. So if we save that, JUnitMax runs the tests, and it reports we're expecting 5, but we get 4. Now at this point, probably the simplest thing I can do that will pass all of the tests is to actually reuse some of the code we've already written in a recursive type of way. And if I save that, all the tests are passing, and what we actually have here is a general recursive algorithm for naming any Fibonacci number at any position in the Fibonacci sequence. And we've done that by triangulating through concrete examples and generalizing as we go. We've removed all the duplication from the code, so our code is as clean as we can make it. And that, my friends, is test-driven development.